Okay, so we are going to jump into normal distribution probability calculations. And so here's 3 problems that we're going to go through that we're going to utilize the calculator for using normal CDF or PDF specific programs in the calculator. So assume that you are given a normal distribution, find the specific probabilities, and you want to make a sketch for each one. So 26. The mean is 60, and the standard deviation, so the mean is 60, the standard deviation is 4.0. Find the probability that x is less than 53. So we want to find that probability. So one, sketch. So if it's a normal distribution, we're going to sketch a normal distribution where the median here is right in the middle. It's 60. Okay, one standard deviation away in both directions would be 4 away, so this would be at 64 and this would be at 56. 2 standard deviations away would add 4 here to 68 and subtract 4 here and be at 52. Right, okay, good. And we are looking for what's the probability that x is less than 53. So 53 is about here, and we want less than 53. So the probability of randomly selecting a value less than 53, 53 is right here, would be the area, the red area under this curve. So there's a couple different ways to approach this problem. We could find out how many standard deviations away 53 is from 60, calculate a z-score, go to the A2 table and find the area to the left, or we can just use our calculator and calculate the normal, I'll write down first, normal commutative distribution function of the values that were given. The specific value, lower bound, the lower bound would be negative infinity, but we can't put that in the calculator, comma, the upper bound would be 53, and then all the way up to 53 with the mean of 60 and the standard deviation of 4. So we can put this into our calculator the best we can. So normal CDF function is second vars, gives you the distribution menu. Normal CDF is number 2. And then we put our lower end. The lower end is already generally in there. Negative 1e99, which means negative 1 times 10 to the 99th power. Or we can just type in negative and then put a few 9s in there. The upper bound 53. Mean of 60. Standard deviation of 4. Paste that in. That's exactly what I said. Hit enter. Boom, boom, boom. This is actually equal to that area right here, 0.04. So the probability of getting an x value less than 53 would be 0.04 for this specific problem. And this is the sketch for that problem. Normal distribution, label some standard deviations, and identify your specific value relative to everything else. Okay, the second one, the mean is 15, so 27. The mean is 15.2. The standard deviation is 0.9. You want to know what's the probability that x is greater than 17. So here we're told, or again, that it's a normal distribution function. So it's supposed to be symmetric. Still working with this board that I have. With the middle, median is the mean, 15.2. One standard deviation above would be 15.2 plus 0.9, so 16.1. And then one more standard deviation above would be 17 exactly. One standard deviation below, two standard deviation below. I don't really need to worry about that because I'm focusing on above 17. I want to know, right at 17, what's the probability that we get someone greater than 17? And 17 is actually 2 standard deviations right above. So we should actually know this area already because it's the above 2 standard deviations from something. But let's calculate it anyway, nonetheless. So we would do a normal CDF from technically from 17 to infinity, where the mean is 15.2 and the standard deviation is 0.9. See now here, because I'm calculating the area above a value that goes infinitely this way. So that's why the infinite, or the very large number here in the calculator, I'm just going to write a bunch of 9s, okay, is the upper bound. So we'll run the same function, normal CDF, from, in this case, 17 all the way up to an upper bound of lots of 9s, where the mean is 15.2 and the standard deviation is 0.9. And we get a value of 0.02275, 0.02273. And we should have known that already because roughly, right, I'll use another color here. Roughly 95% of all the data lies between 2 standard deviations. So outside of it, total is 5%, so about 2.5%. So it's close. So 0.023 would be the answer for 27, going above a value. Now this last one, you're told 28, that the mean is 22, the standard deviation is 2.4, and you want to know what's the probability that your value is between 25.3 and 19.7. So it's actually between 2 values. Okay, so normal distribution function here. The mean is 22. Standard deviation is 2.4, so 2.4 above would be 24.2, and then 2 more. 2.4 would be 26. Oh, whoa. 24.4. So 26.8. That's as high as I need to go. And then going down, minus 2.4 would be 20. So 19.6, and then minus. Actually, don't even need to go that. I don't need to go that much further for this specific problem, so I won't. Because I'm going between 19.7, which would be here, right above 19.6, and 25.3, which is somewhere in the middle. So I want to know this area, right? Randomly selecting a value between these numbers of 19.7 and 25.3. So actually this problem with the calculator, again, is not difficult. We're going to find the area between these 2 boundaries. So the boundaries are given for us. So to calculate this probability, we were just, again, it's normal distribution, so normal CDF function between the values of 19.7 and 25.3, with the mean of 22 and the standard deviation of 2.4. And this will give us our probability. So between 19.7, 25.3, mean of 22, standard deviation of 2.4, 0.746, 0.746. And that should make sense because it looks like a lot, right? A relative lot of the area, about 3/4 of the area. Okay, and it should also make sense because it's one standard deviation would be almost 70%, right? 68% of the area, and we're somewhere between 1.5-ish standard deviations in both. Well, one standard deviation to the left and 1.5-ish standard deviations to the right. So the number should make sense. So that was looking at calculating probability under a normal distribution curve. Different examples.